The next thing we want to look at are solving linear equations that have fractions as the coefficients. So the goal here is when you have fractions instead of whole numbers or integers, we want to still be able to solve those linear equations. So we'll start with one option. One option that you can do when solving these is just to treat it like a normal linear equation you've seen before. So let me just recall something. If you were going to solve 2x minus 1 equals 5, the first thing you would do is you would add 1 to both sides. You would get 2x equals 6. Then you would divide both sides by 2, and you would get x equals 3. So you probably wouldn't have any problems with that one. Just because we have fractions in this example doesn't mean you should treat it any differently. The first thing I'm going to do is add 7 halves to both sides. When I do that on the left-hand side, I'll be left with 3/4 x. The only issue is to add 5/6 and 7 halves, you need a common denominator. Well, 6 is a common denominator, so I'll rewrite 7 halves to be 21 over 6. So I multiplied the top and bottom by 3. Then I'll add them together, so I'll get 26 over 6. And before I go any further, I do want to reduce that fraction. Otherwise, I'm going to have to do it later. So 26 over 6, I think that's 13 over 3. So I divided both the top and the bottom by 2. I pulled out that factor of 2. Next, if you're looking back at my kind of simplified example, we divided by the coefficient. So I'm going to divide both sides by my 3/4. On the left-hand side, we'll just be left with x, and then on the right-hand side, I'll have 13/3 divided by 3/4. Now remember, to divide fractions, we take the second fraction and we multiply straight across. And when I do that, I'm going to get 13 times 4, which is 52, and then 3 times 3 on the bottom, which is 9. So there's nothing wrong with this way. We just treated the fractions like we used to with the whole numbers and solved for x. A lot of people, though, don't like working with fractions, and I totally get it. If you don't like working with fractions, that's fine. You just have to be able to get rid of all the fractions. So what I can do is I'm going to look at the least common multiple of every denominator in this problem. So my denominators are 4, 2, and 6. So least common multiples, I'm going to list out all the multiples. So for 4, the multiples are 4, 8, 12, 16. It keeps going. For 2, the multiples are 2, 4, 6, 8, 10, 12. It keeps going. And the multiples of 6 are 6, 12, 18. It keeps going. I want the smallest number that appeared in all 3 of these rows, and it looks like 12 was the smallest. So that's going to be my least common multiple. What I'm going to do is take that 12 and multiply everything in my problem by 12. So I'll multiply my 3/4 x by 12. I'll multiply the 7 halves by 12. And I'll multiply this 5/6 by 12. And we're allowed to do this. All we're doing is multiplying the equation. But as long as you do it to every piece of the equation, it's fine. Now the reason I do this is because I'm going to be able to get rid of all my denominators. Take this first one, for example. I'm dividing by 4, so I'm going to rewrite 12 to be 3 times 4. And some things are going to cancel. For the next part, I'm dividing by 2, so I'll rewrite 12 to be 6 times 2. And for my last one, I'm dividing by 6, so I'll rewrite 12 as 2 times 6. So what ends up happening? In my first part, the 4's cancel. In my second piece, the 2's cancel. And in my last one, the 6's cancel. So that leaves me with 9x minus 42 equals 10. So this is an equation that's maybe a little easier. It's the same equation. We just multiplied everything by 12, and now we have this. So to solve, it's a two-step equation, I will add 42 to both sides. So add 42, and that gives me 9x equals 52. And then lastly, divide both sides by 9. And we get the same answer that we got before. So you can kind of decide which way is easier for you. Some people like fractions, some people don't. I think a lot more people tend to not like fractions. So just remember to multiply through by the least common multiple, and then you can get rid of them. So do a couple of examples here. My first equation, or my first example, 2/3 x minus 2 equals 3/2 plus 6. So I'm going to start with finding a least common multiple of every denominator in the problem. So a least common multiple of 3, 2, and 6. Like I've done before, you can list out all the multiples, and that's fine. Nothing wrong with that. It looks like the smallest number that was listed in each row was 6. So we'll go through and multiply each piece by 6. So 6 times 2/3 x minus 6 times 2 equals 6 times 3/2 plus 6 times 1/6. What we're doing, and maybe this isn't obvious, what we're doing is we're multiplying this side by 6 and then multiplying the right side by 6. And when we do that, we have to distribute. So that's why we're multiplying everything by 6. For my first piece, I'm dividing by 3 on the bottom, so I'll write 6 as 2 times 3. I still have my 6 times 2. Deal with that in a second. Next, I'm dividing by 2, so I'll rewrite this 6 as 3 times 2. And then we're going to leave this one alone. All right, so in my first one, looks like the 3's are going to cancel, which leaves me with 4x. 6 times 2 is 12. Looks like the 2's will cancel in this next piece, so I'm left with 9. And the 6's will cancel, which leaves me with 1. So 4x minus 12 equals 9 plus 1. I would start this by combining the 9 and 1. So 4x minus 12 equals 10. And now this looks like a two-step linear equation. I'll add 12 to both sides. So 4x equals 22. And then divide both sides by 4. So I get x equals 22 fourths, which we can reduce. We can reduce that down to 11/2. Next, let's look at 3/2 times 5/9 x plus 4/27 equals 3. And there's a couple ways you could do this one. I would probably start by getting rid of this coefficient. So let's go ahead. What could I multiply both sides to get rid of that coefficient? Well, I could divide both sides by 3/2. And that'll give me 5/9 x plus 4/27 equals, and now what is, I'll do this off to the side, what is 3 divided by 3/2? Remember, you take the second one and multiply straight across. This 3 is really 3/1. These 3's will cancel, so I get 2. So I have 5/9 x plus 4/27 equals 2. You could definitely just do this as a two-step linear equation, but I don't really like working with fractions, so I'm going to multiply through by the least common multiple. The least common multiple of 9 and 27, so I could list them out if I wanted to, or you could notice that 27 is a multiple of 9, so 27 kind of has to be your answer. So I'll multiply 27 on both sides of this equation. For my first one, it's going to give me 27 times 5/9 x plus 27 times 4/27 equals 2 times 27, which is 54. For my first piece, I'm dividing by 9, so I'll rewrite 27 to be 3 times 9. And the 9's are going to cancel. For my second piece, it's already 27 on the bottom, so I'll just leave it there. Once I cancel out those 9s, that leaves me with 15x plus the 27s cancel, and I'm left with 4, equals 54. Once you get to this point, it's a two-step problem. I'm going to subtract 4 and get 15x equals 50. Then divide both sides by 15. So x equals 50 over 15. But 5 goes into both of those, so we can reduce this down to 10 thirds.